So in this part of the video, we're going to start to look at relational data based on the conceptual models that we had come up with for our library system. So when we left off, or rather when we started kind of talking through our models and our data, we kind of came up naturally or intuitively to this point that we have books and those books have authors, and that there's some kind of relationship here that exists, that you can have an author publish multiple books, you could potentially even have multiple authors on the same book. So how do we capture that in a database design, in a database table? So if we go back and we look at the table we created for our books, we created a column for author, and it was of type string. Well, obviously there's a lot more data that we can store about an author than just their name in a string field. So in order to do that, we're actually going to start by creating another table for authors. So in our author table, we kind of came up conceptually with some of these elements, and again, this is not extensive, this is not complete, this is more for presentation. So if you think of another idea of, hey, it would be nice to store this information about an author, or hey, I know something about libraries, really we should be storing this data about an author, great. I'm sure if there's someone that has more knowledge about authors and library systems, you probably could come up with a whole bunch more things that I've excluded. But for our example, we're going to go with we're going to create an ID column for the identifier. So each author has a unique primary key, a unique ID. We're going to then put a first name field as a string, last name field as a string, a birth date as date time, and then we'll have like a publisher location as a string. And I've made first name, last name, and birth date required just because you kind of need all of those to make the person identifiable. And everybody has those three things, and then you've got the publisher location as not required. So our table of author data would look something like this. I extracted the authors from the book table example and just kind of shoved them in here. So we've got this data then about our authors. We've got our ID, first name, last name, publisher location, and birth date. So now the question becomes now we have authors in a authors table, how do we then relate the two together? Now, in past lectures and past videos and potentially even past classes, you've learned about joins and joining data together. This is where that join starts to come into play, is that now we have a book, we have a row of books in one table, or rows of books in one table, and we have rows of authors in the other, and the two need to be related together. So what I want to do is, instead of having author as a string in my books table, I want the author ID, the ID column from the authors table, to then become a foreign key inside of my books table. So whatever ID my author has in the table on the right, let's say it's ID number 1, if that author wrote that book that's in my books table, then that ID of 1 should end up in my books column, author ID. And then I can write a select statement with a join, and then join on author ID and ID from the authors table, and now I have related those two together so that I can now have the book and its author presented to me through that select query. So if we were to write a SQL select statement that would actually represent all of this data, it would look something like this. So we'd have select books.star, so selecting all of the columns from books, and then adding the author ID, author first name, author last name, and then we say from books inner join author on books.author underscore ID equals author.id. So that idea of joining and relating the two data tables together to create still a cohesive presentation. So the result set would look something like what we have here below. So we still have the title. We would have the author underscore ID column coming from the books table. That would give us the primary key of the author row. We then have still the ISBN, the page count, publisher, copyright, and then we would actually kind of append on the columns from the author table. So we'd have the author ID again. So this column and this column are actually the same column data, not the same column, but the same column data in two different tables. So this The one on the left comes from books, the one on the right comes from author, and then we would have the first name and last name from the author's table. So these last three columns actually come from the author's table itself. Everything else comes from the books table. So that idea of creating that inner join allows us to link the related data points together to get one presentation of that data. So that's the power of having relational data sets, is that we could in theory then have multiple books written by the same author, which we don't have demonstrated here, but that ability then to say we have this author who wrote these two books. Both of those books would have the same author ID because they're both related to the same author. And likewise, we could say give us all the books that are written by a particular author, an author with the author ID of 4, and we would get a list of all those books written by that author. That's where the power starts to come in, is that you don't have to search by name, you don't have to worry about data inconsistencies where someone maybe had typed, so if we look at author ID 5 here, author ID is Brendan Wenzel. If someone typed it Brendan one way and then Brandon another way because it was a misread or a mistype, you don't end up with ambiguity because you always know that Brendan Wenzel is always author ID 5. So his primary key within our table is 5. So any books related to him would simply have an author underscore ID of 5. So that again helps ensure data integrity, consistency, things that you don't get with simple spreadsheets. So that's kind of a high level view, going a little deeper into the construction and building out of databases and their tables. We'll get more into the mechanics of how to actually go through this next week with the types of statements and the tools that you can use to build these. I hope that you've kind of gotten a little bit of a better glimpse into how databases are structured and how they work and what's required to get a database working correctly, and kind of again going from that conceptual, this is the scenario that I'm dealing with, this is what I'm expected to do, I need to build a database for this software, for this scenario, for a library or a school or something like that, or for Kroger, for a grocery store, tracking inventory, products by brand and things like that. And now your brain is starting to think, oh, so that's how those pieces should relate. I should have a table of brands, I should have a table of products, maybe a table of suppliers that supply me those products. Those all could have primary key, foreign key relationships and start to link together. Alright, so start looking around the world and start to see how maybe you could build databases for things that exist in the world.